Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important question, that is from electromagnetic theory. Already we are discussing so many classes I am uploading in YouTube channel, that is electromagnetic theory core syllabus of CSIR questions I am discussing. The old question, these are all old questions only. You have to check in your old question paper also the paper question is there or not. You are able to see I am giving the question when this question came, also I am giving to you. This question is very important. This question belongs to the Poynting vector. In electromagnetic theory, so in classical mechanics we are discussing about the energy conservation principles, momentum conservation, angular momentum conservation, energy conservation. So like this we have to discuss the conservation principle in classical mechanics we are discussing. In the similar fashion we are going to discuss about a conservation laws in electromagnetic theory also. So what is the first conservation principle is the equation of continuity, that is the energy conservation, that is the charge conservation principle, and the second one is Poynting theorem, this is the energy conservation principle. Poynting vector we also call it as a energy flux density also. Clear? This is the introduction I have to teach to you. So already in our app in detail we are discussing, but in for canvassing purpose only I am teaching the questions for different areas I am teaching to you. First you have to see in CSIR June 2013 there was a question based on the Poynting vector. This question based on which one? This question purely based on the Poynting vector only we are asking. This question is purely based on which? Poynting vector. A eye is created by a narrow beam of protons. A current I is created by a narrow beam of protons. There is a I is created. So that I is because of what? Because of a narrow beam of protons moving in a vacuum with constant velocity. So what is moving? Moving is vacuum with constant velocity v. So therefore you have to take it is a linear system, that linear charge density is equal to lambda. Along which direction it is going? Along the z cap direction it is going, like that you have to take. So once again you have to listen. The current I is created by a narrow beam of protons moving in a vacuum with constant velocity u. The direction and magnitude, respectively of the Poynting vector S. The direction and magnitude respectively of the Poynting vector S outside the beam at a radial distance that is much larger than the width of the beam from the axis is we need to calculate. How we have to calculate? Once you have to see, we know that I is equal to lambda into V. I is equal to lambda into V, but we are taking this is a linear current lambda into U. In which direction it is moving? The z cap direction it is moving, that is I is equal to lambda into U I have to write. So the Poynting vector we need to calculate direction and magnitude, we have to calculate the radial distance r from the axis. The radial distance r you have to take from the axis at particular point P. Here we need to calculate the Poynting vector, we have to calculate. How we have to calculate the Poynting vector? You know that the magnetic field at a distance r is given by, you know that the magnetic field at a distance r is given by, the magnetic field at a distance r is equal to, what is the magnetic field? Already we discussed in the previous classes. So what is your magnetic field? Is the magnetic field at a distance r is equal to B is equal to mu naught I is divided by 2 phi r. In which direction it is going? it is going in the phi cap direction, it is going. This is the magnetic field, because we need to calculate the Poynting vector. For calculate the Poynting vector, we need to know the electric field and the magnetic field. Clear? So, the electric field at a distance r is given by, so therefore, what we have to write it is the electric field at a distance r. The electric field at a distance r is given by, electric field at a distance r is equal to, for a infinite wire you have to take, that is a lambda by 2 phi epsilon naught into r. In which direction it is going? The electric field is going in a r cap direction, it is going. So, the direction you have to take it as a r cap direction. Clear? So, the direction you have to take it as a r cap. So, lambda is equal to I by lambda, I is equal to lambda into u. So, therefore, you are able to take, you have to substitute here. So, lambda is equal to I is divided by 2 phi epsilon naught into r into u. So, 2 phi epsilon naught into r into u, in which direction it is? The electric field is in r cap direction is there. Now, we need to calculate the Poynting vector. We have to calculate. How we have to calculate the Poynting vector, you able to see. The Poynting vector S is equal to E cross B is divided by mu naught. E cross B is divided by mu naught. This is the formula. But you know that E is equal to, what is your E? So, I by 2 phi epsilon naught into u into r. In which direction? This is r cap direction, cross, what is your B? Mu naught I is divided by 2 phi r. In which direction this B is? Obviously, this is a proton wire, proton passing wire, phi cap direction is there. Clear? Now, you have to take mu naught. So, is there any cancel terms? Mu naught I square is divided by 4 phi square into epsilon naught u r square is there. So, this direction is r cap dash phi cap is there. But you have to take it is a cylindrical coordinate system, r phi z, r cap phi cap is equal to, you have to write it is, that is a z cap. So, therefore, your Poynting vector S is equal to mu naught I square is divided by 4 phi square epsilon naught into u r square. In which direction it is? That is going to take it as a z cap direction is there. Clear? That is the z cap direction. Now, you have to observe here. So, there is a u is going in which direction? That is in z cap direction is going, correct? Here S also going in which direction? That is also going in z cap direction. Therefore, both are going in the z cap direction. That is why S is parallel to u. S is parallel to u. So, this S is parallel, the direction is S and u both are parallel direction, and your Poynting vector is mu naught I square 4 phi square epsilon naught u r square is there. Now, you have to check the answers. So, what are the your answer? S is perpendicular is not correct. S is minus parallel is not correct. S is parallel to u, and S is equal to the modulus of S they are giving. The modulus of S is equal to I square by 4 phi square epsilon naught, the modulus of u into r square. So, that is one you have to write it is. Here what we have to take? The modulus of S is equal to mu naught I square is divided by 4 phi square epsilon naught into the modulus of u into r square we are getting. This is the, which vector it is? This is a Poynting vector corresponding to your problem. We have to do this. So, already I am informing you. So, daily I am teaching. So, I am informing. So, CSIR and GATE online coaching we started. This is purely physics content only. So, if you really likes my teaching, if you really think, because so many days I need to teach to you, So maybe more than 1 year it will take place, because 2 papers only now completed. We are under the electromagnetic paper only, electromagnetic theory. So remaining 6 papers are there. The 6 papers I only need to teach, that's why we have to take so much of time. If really long term goal, if you have to learn the physics subject, you utilize this coaching institute. This is purely online mode, right? So 2 years validity is there for CSIR. 1 year I need to take the classes. 1 year you have to listen and practice the things. So DL physics content or JL physics content is available. So better you join in the CSIR. Those classes only I have to upload according to as per the syllabus of the JL or DL. So I have to insert that videos in that one only. Clear? So please try to understand. So utilize the chance, CSIR and GATE physics course. If you want to really crack, if you want to really learn the subject, you have to take this course. This course will help you so much of knowledge will give you in the physics side. So therefore this course, if you once you download my app, the courses will appear like this: CSIR and GATE, JL and DL. Mathematics individual papers also is available. So mathematical methods of physics, classical mechanics and electromagnetic theory. So now the electromagnetic theory live class is going on. If you have to join now, only live classes, and after taking the live there is a recorded mode also. 1 year validity is there. If you want to take individual papers, you have to take. So right now only 3 individual papers we have. So maybe a couple of days, 1 paper by 1 paper we have to add in that, right? Maybe in the month of June itself we have to wind up this electromagnetic theory paper. So please share and subscribe and like our YouTube channel, and you have to listen the physics classes including science and technology also. Thank you so much.